Hello and welcome back to another episode of Measurement in a Minute. I'm your host, 𝗦𝗧𝗔𝗬𝗧 with Lakeside Process Controls. And in today's episode, we're continuing our discussion around Rosemount magnetic flow meter technologies. In particular, we've been talking through our solutions for slurry applications, and today we're talking about adaptive signal processing, which is a new feature, part of our slurry solutions. So to understand this, let's look at a graph. And on the x-axis, we have time, and on the y-axis, we have flow rate. Our magnetic flow meter is taking 12 data points per second and analyzing each one of these data points, and this is what really adaptive signal processing is all about. So at point 1 here, we can see a few different things. So the x are going to be our measured variable, or our measured data point that is going directly into the mag, and then the O is going to be the outputted variable. Okay, and so what it is doing is it is actually adjusting its output by taking an average, quite simply. And what it is doing beyond this, a little bit more sophisticated, is it's looking at and it's setting a threshold for where it expects values to be. Okay, so based off of nominal variance, it is setting these thresholds, which are represented by these horizontal bars. Okay, so as you can see, after the second data point, we kind of had a little bit jump high. That's why we had a little bit of a threshold change on the upper side. And then as we started to have lower data points, then we started to see both of those thresholds actually drop. In either case, though, we have a pretty consistent, stable output that you'd have no issues controlling a valve off of, let's say. Then we have point number 2, and this is really where the sophistication of the adaptive signal processing comes into play. Point 2, a measured variable that is way beyond our expected threshold. Now, instead of initially reacting, the magnetic flow meter takes it into consideration, but does not use it for the average. It's waiting for the next point to validate, is this actually a good and true measured value, or is this just maybe spike noise, for instance? And as you can see, the next point is within the threshold, and you can see point 3 and 4 beyond that is within that threshold. So point 2 is just ignored as spike noise, not included in the average. Okay, and as a result, we have a consistent, stable measurement that, again, we can still control off of. Okay, now point 4 comes along, and point 4, similar as point 3, we look at it, we acknowledge it, we do not include it in the average, we wait for another data point. And then what you're seeing is consistent measured values that are at that data point, validating the true flow rate is actually at this point, even though it's way beyond that threshold. And so the algorithm will step its way up to this in a gradual fashion until in point 5, we now have actually a tight threshold around this point because we're getting very consistent measured values at this elevated point. Okay, so adaptive signal processing is really a more sophisticated way to dampen. So we acknowledge which measured variables are statistically significant and which ones are not. We make adjustments accordingly. So this gets us the best of both worlds. We now have a good stable output that we can control a valve off of, but we're also not having a time delay in the measurement, so we can react as the flow rates actually change. And I'll show you how this impacts things. So if we look at this example here, an iron ore 64% solids, this is a real data actually testing our different transmitters. If we use our standard transmitter, not the Slurry platform, we have two options, a 5 hertz version of the transmitter or a 37 hertz. And for our Slurry platform, we have a low or a high frequency. And so this yellow is actually this standard transmitter at 5 hertz. And you can see that there's pretty significant variance. And then if we look at increasing it to a higher frequency, the 37.5, you can see there is an impact because now we have stronger signal to noise ratios, so we're more confident in our signal. But then if we look at using our 8782 at the low frequency, it is essentially a flat green line by comparison to these other two. And the only difference, besides a slight difference in the frequency, is going to be this adaptive signal processing. So I think this is a really powerful graphic to illustrate the impact of this technology. Should you have any questions about Rosemount's magnetic flow meters or any other of our products, please reach out using the QR code to my left. Thanks and have a great day.